Acids, bases, and salts are fundamental in chemistry. They are involved in many natural and industrial processes. Acids have a sour taste and release hydrogen ions in water. They turn blue litmus paper red. Bases are bitter, release hydroxide ions in water, and turn red litmus paper blue. When acids and bases react, they form salts through a process called neutralization. This reaction cancels out the properties of the acid and base. Acids, bases, and salts are found everywhere, from food to factory products. The pH scale measures how acidic or basic a substance is, which is crucial for controlling reactions in labs and industries. An acid-base indicator is a chemical compound that changes color when the pH of a solution changes. There are three main types of indicators: natural, synthetic, and olfactory. Natural indicators come from plants, such as litmus, turmeric, and red cabbage extract. Synthetic indicators are man-made, like methyl orange and phenolphthalein. Olfactory indicators change smell when exposed to acidic or basic solutions. Examples include onion strips, vanilla essence, and clove oil. These indicators help determine if a solution is acidic or basic. Acids react with metals to create a salt and release hydrogen gas. For example, zinc and dilute sulfuric acid produce zinc sulfate and hydrogen. Magnesium and dilute hydrochloric acid produce magnesium chloride and hydrogen. You can identify hydrogen gas by the bubbles it forms in soak solution or the pop sound it makes in a burning candle test. Reactive metals like zinc also react with strong bases to produce hydrogen gas. Metal carbonates and hydrogen carbonates react with acids to produce a salt, carbon dioxide, and water. This reaction can be seen when sodium carbonate or sodium hydrogen carbonate is mixed with hydrochloric acid, releasing carbon dioxide. Acids and bases dissolve in water and split into charged particles called ions. Cations have a positive charge, while anions have a negative charge. For example, hydrochloric acid forms hydronium and chloride ions in water. Bases like sodium hydroxide release sodium cations and hydroxide anions. Acid and base solutions can conduct electricity due to the presence of mobile charged particles, typically hydrogen or hydroxide ions. Water is essential for this process, as acids and bases only show their properties when ionized in aqueous solution. Dilution is the process of decreasing ion concentration by adding water. When you add water, the number of ions stays the same, but they spread across a larger volume, so concentration drops. Dissolving certain substances in water releases heat energy, an exothermic process. This is especially true for concentrated sulfuric acid and sodium hydroxide. To stay safe, always add acid to water, not the other way around. Adding water to concentrated acid can cause a violent reaction, leading to splashing and serious burns. Instead, slowly add acid to a larger amount of water, allowing heat to dissipate gradually and reducing the risk of splashing. The pH scale measures how acidic or basic a solution is. It runs from 0 to 14. The scale checks the concentration of hydrogen ions. Values 0 to 3 indicate a strong acid. Values 4 to 6 show a weak acid. At 7, a solution is neutral. Values 8 to 10 represent a weak base. From 11 to 14, you have a strong base. Strong acids, like hydrochloric acid, completely ionize in water. Weak acids, like acetic acid, only partially ionize. Strong bases, like sodium hydroxide, fully dissociate in water. Weak bases, like a sodium hydroxide, partially dissociate. A universal indicator helps measure exact pH values and determine if acids or bases are strong or weak. Your stomach produces hydrochloric acid to break down food. Too much acid causes indigestion. Antacids like milk of magnesia neutralize excess acid. Tooth enamel corrodes when mouth pH drops below 5.5. Bacteria produce acids, causing decay. Basic toothpaste helps neutralize these acids. Soil pH affects plant growth. Farmers add materials like calcium oxide to restore pH levels when soil becomes too acidic. Acid rain occurs when industrial emissions mix with moisture, damaging ecosystems and buildings. Bee stings and nettle plant stings inject acidic venom. Applying baking soda provides relief by neutralizing the acid. Salts are grouped into families based on the ions they contain. The sodium family includes NaCl, Na2SO4, NaO3, and Na2CO3. The chloride family has NaCl, KCl, KaCl2, and MgCl2. The sulfate family includes Na2SO4, ZnSO4, and KuSO4. The pH of a salt solution depends on the acid and base used to make it. A strong acid and strong base produce a neutral solution with a pH of 7, like sodium chloride. A strong acid and weak base produce an acidic solution, like ammonium chloride. A weak acid and strong base produce a basic solution, like sodium carbonate. The chlor-alkali process involves passing an electric current through brine, a solution of salt in water. This breaks down the salt and water molecules, producing sodium hydroxide, chlorine gas, and hydrogen gas. Sodium hydroxide is used in manufacturing soap, paper, and textiles, as well as in drain cleaners and food processing. Chlorine gas is used in water purification and producing PVC plastics and insecticides. Hydrogen gas is used in ammonia synthesis for fertilizer production and as an energy source in fuel cells and in the food industry for hardening vegetable oils. These products are used in many aspects of daily life. Bleaching powder is calcium hypochlorite. It is made by reacting calcium hydroxide with chlorine. Bleaching powder is used to bleach materials and disinfect water. Baking soda or sodium hydrogen carbonate is a mild basic salt. It is used in baking and as an antacid. Washing soda is sodium carbonate decahydrate. It is used in manufacturing and as a cleaning agent. These substances have different uses and properties. They are all types of salts with specific functions. Acid and metal reactions produce a salt and hydrogen gas. Base and metal reactions also produce a salt and hydrogen gas. Acid and carbonate reactions result in a salt, carbon dioxide, and water. Acid and base reactions produce a salt and water. Metal oxide and acid reactions yield a salt and water. Non-metal oxide and base reactions produce a salt and water. In these reactions, two substances combine to form specific products. Salts are common products in most of these reactions. An acid-base indicator changes color when the pH changes. It's a chemical substance that reacts to pH levels. An alkali is a base that dissolves in water, producing hydroxide ions. Ionization occurs when a substance forms ions from neutral molecules. There are two types of ions: anions, which are negatively charged, and cations, which are positively charged. The hydronium ion is a protonated water molecule and is the active acidic species in solution. Acids and bases can be strong or weak, depending on how they dissociate in water. A strong acid or base completely dissociates, while a weak one only partially dissociates. The pH scale measures hydrogen ion concentration, ranging from 0 to 14. Neutralization occurs when an acid and a base react to form a salt and water. Substances can be diluted by adding solvent, reducing their concentration. Processes can be endothermic, absorbing heat energy, or exothermic, releasing heat energy. Water of crystallization is water bound within a crystal structure. Antacids use magnesium hydroxide or sodium bicarbonate to neutralize excess stomach acid. They work similarly in toothpaste, neutralizing bacterial acids. Sodium bicarbonate helps dough rise when baking by producing carbon dioxide gas. Bleaching agents like calcium hypochlorite remove color from fabrics by oxidizing them. Fire extinguishers use sodium bicarbonate and sulfuric acid to generate carbon dioxide, smothering flames. Water purification uses chlorine or calcium hypochlorite to kill microorganisms. Farmers use calcium compounds to neutralize acidic soil. Medical plaster casts are made from calcium sulfate hemohydrate, which hardens when mixed with water.